This video is on factoring quadratics. We're going to be factoring quadratic trinomials using guess and check. These are three more examples of using guess and check to factor. Question 4, x squared minus 5x plus 6. We need to find our GCF. The smallest number on this problem is a 1, so we know our GCF has to be a 1. Then we have x, no x. Our GCF is 1. It will not affect the problem. Let's go ahead and discuss the signs. We have a positive c value, so we're going to have the same signs. And we have a negative bx term. That means that both will be negative. So we know that inside of a parentheses we'll have two negatives. Find the factors of x squared are x and x. The factors of 6 are 1 and 6, and then 2 and 3. We're going to put our factors inside of our parentheses. We're going to put our x and x in the front because that was the front factors. We know that they're both going to be negative, so we can go ahead and put that minus sign in between them. And then we're going to put the factors of the 6 in the back. So I'm going to start with the 2 and 3 because those are the ones that are on the bottom of the chart. So 2 and then 3. Now 2 and x are fine, 2 and x are fine, 3 and x, 3 and x. That's fine, so we can put these together. Now we want to check this by doing our multiplication. So we have negative 2x and then negative 3x. And because we already have our signs, we can go ahead and combine these as they are. So negative 2x minus 3x is negative 5x, and that's the bx term, which is what we wanted. So this is good. That means that we're already done. We already have our answer. So our answer is x minus 2 and then x minus 3. Those are our two factors that would distribute back to give you the original. This next problem, number 5. 2x squared minus 9x minus 18. We've got to find our GCF. Our smallest number is 2. 9 cannot be divided by 2, so it's not going to be 2. Then it's 1 times 2 gives us the 2, so then our GCF has to be the 1. We have an x, no x. Our GCF is just 1, so it will not affect the problem. Talk about our signs. We have a negative c value. That means that our signs are different from each other. That means one will be positive and one will be negative. So our bx term is a negative bx term. That means that the bigger multiplication, the part when we do the insides and outsides, the bigger of those multiplications will be negative because it's a negative bx term. So we'll have a negative in there. But the thing is that we don't want to deal with the signs until the very end when we get our multiplication, because we won't know which one will have to be positive, which one will be negative inside the parentheses. So we focus on the 2x squared is 1x and 2x, and that's all that will multiply to that. Then we have our 18, which is 1 and 18, 2 and 9, and then 3 and 6, and that's it. So these three. This has more in it, so again, we want to make sure that we use all of our helpful hints. So I'm going to have parentheses. Go ahead and put in our 1x and our 2x. And now we want to put in our back terms. I don't want to focus on the signs yet. Now, always look back at our helpful hints. We have the helpful hints for the signs, which we're going to deal with at the end. The other helpful hint was no common factors. This 6 cannot go into this set of parentheses, so that actually eliminates one of my guesses. This 2 cannot go into this set of parentheses. That eliminates the second guess. And this 18 also cannot go into this set, so that eliminates 3 of our 6 guesses. So we actually have half the work to do. They can't go into this set of parentheses because they have a common factor. So I'll actually make a note about that. I'm going to dot them up. These cannot go into with the 2x. So it has a common factor, so has common factor with the 2x. So we don't put in the same parentheses with the 2x. Because we already found our GCF was 1. If we put it in here with the 2 again, we'd have a GCF, but our GCF was 1. So that means that we can't put them together. So that means that this 6 has to go into this first set, and the 3 would have to go with the 2. So we put our 6 in the first one, and then our 3 in the second one. So now that was our first guess, so now we're going to check it. So inside is 6 times 2 is 12, and then we'll have the x, and then x times 3 is 3x. So now that we have our multiplication, the bigger multiplication should be negative. 12 is bigger, so I'm putting negative 12 and a positive 3. Now negative 12 plus 3x equals to a negative 9x. And that's what we actually wanted. We go to the bx term, that's what we want. So this is good. So actually our first guess was good. Now we just have to put the correct signs. The negative is attached to the 2 and the 6. The 2 has to stay positive because it's in the front of something. So then it's the 6 that will be the negative. And if we follow the positive, positive, and positive. So our answer will be parentheses x minus 6 times parentheses 2x plus 3. This last example, we have 4m squared minus 4m squared n squared plus m cubed n squared. There's a lot of letters, so I'm not even going to try and put them in correct order yet. I want to factor out the GCF so I can see which letters we need to focus on. So GCF. Our smallest number is a 1. We have an M, and M, so they all have an M, so we can factor out an M. The smallest is M to the first, so we can factor out an M to the first. Then we have an N. They all have N, and they all actually have N squared, so we can factor out an N squared. So let's divide and get our new trinomial. So we have M n squared on the outside, m n squared on the outside as your GCF, divide by m n squared. 4 m n squared divided by m n squared is just 4. Minus 4m squared n squared divided by m n squared is just 4m. Plus m cubed n squared divided by m n squared is just m squared. Now we have a lot less letters to look at, and we see a trinomial. Our quadratic term is back here. We need to rewrite that. So let's rewrite this as m n squared parentheses. We want our quadratic term first, which is a positive m squared. Then we want our linear term, which is our m. That's a negative 4m, so we have to keep that negative 4m together. And then our constant term, which is that positive 4. We just rewrote that. Now we can figure out our ax squared, our bx, and our c. Okay, so now we can look at our signs. We have a positive c term, that's that 4, so we know we're going to have the same signs. And we have a negative bx term, which tells us that both of them will be negative. So we focus on the m squared, and we know it's going to be m times m. We have our 4, which is 1 and 4, and then 2 and 2. So parentheses. we can go ahead and put in our m and m. We already know our signs as well. Just figure that out. So we can go ahead and put minus and minus. And now we focus on the back. So I'm going to focus on the 2. 2 and 1 are fine together, so I can put the 2 in both of these. And now we are checking. Now if I should already go ahead and look at my BX term. Can a 2 and 2, when I multiply this, give me that 4? Most likely yes. So this should be right. Let's check it. That becomes a negative 2m. That becomes a negative 2m. So negative 2m minus 2m is equal to a negative 4m. Is that what we want from inside here? Yes. So that means that we are correct. So our GCF was that mn squared, parentheses, m minus 2, parentheses, parentheses, m minus 2. This is our final answer. Now this is actually called something very special. Okay, we can write this a different way as well. I'm going to put an or here. Because these are written the same, anything times itself, so if it, just like here, this is m times m gives us m squared. Well, this is m minus 2 times m minus 2. So this is really mn squared times m minus 2 squared. Because it's m minus 2 times m minus 2. This is the same thing, and you do need to recognize that this is just m minus 2 written twice. This is actually, it has a special name. Okay, so again, that m minus 2 times m minus 2 is actually the same thing as m minus 2 squared. And that actually means that this part right here, this trinomial, that m squared minus 4m plus 4 is a perfect square trinomial. Perfect square trinomial. Now we've dealt with difference of squares where we had a perfect square, and a subtraction. A perfect square trinomial, you still have 3 terms. So if we look at this, we have a perfect square in the front, a perfect square in the back. The difference between a difference of squares, obviously there's only 2 terms in that one, but this one has 3, is in a difference of squares, the middle term has to cancel out. That's why you have a plus b and a minus b. Here, when you take the square roots of both of these, those combined, so those multiplied together, is actually going to be half of that middle term. So the square root of m squared, the square root of 4, so we have m times 2, that's 2m. That is half of 4. That means that that would be a perfect square trinomial. Another example, if you have x squared and let's say 49. So that would be x and 7x. If the middle term was a 14, it would be a perfect square trinomial. Because when you have a trinomial, 2 perfect squares here, if the square roots, if you multiply them, are half of the middle term, this is a perfect square trinomial. And it's just the square roots with the middle sign. So square root of m squared is m, square root of 4 is 2. We still have the middle sign though, negative and a negative. That is how you factor using guess and check, and this is perfect square trinomials. Always make sure you have your GCFs on the outside, and make sure that your multiplications, your parentheses, are multiplied. And you can always check to make sure that this will multiply, distribute it back through to give you your original.